So this is the lesson for Monday, February 6th. And today we're going to be dealing with solving polynomials by factoring. We already know how to factor polynomials. From here to solve them, all you'd have to do is set their factors equal to 0. So I'll go ahead and start with this first one. So this has 3 terms, so we know we're going to factor like we would quadratics. So we find factors of -8 that add together to get -7. That's going to be -8 and 1. So from here we can create our 2 binomials. We know here, since our first term is x to the 4th, and that will have 2 x's here, that each one has to have a squared. Because when we multiply or full it back out, x squared times x squared would give us x to the 4th power. And we know that -8 and +1 have to be our last terms in order for -8 and 1 to multiply and give us -8. Now we just have to check our inner terms, and I'm not going to write it out, I'll just check it verbally. So first terms multiply together give us x to the 4th. We're good on that. Outer terms would give us a positive x squared minus 8x squared. Again, x squared, that's for my outer terms. Inner terms, -8x squared. So x squared minus 8x squared would give us -7x squared. Our last terms, -8 and 1 will give us a -8. If you want to fold that on your own, you can. It will work out. Okay. So from here, we need to solve each one for x. But first we need to ask ourselves, is this fully factored? In other words, could I factor this down more? Or could I factor this down more? And these both have 2 terms, so it's either, and the only thing we've talked about with 2 terms and with the squared is difference of squares. Okay, and the difference of squares formula, I'll write it up here, but it's a squared minus b squared equals a plus b and a minus b. For example, if we had a squared minus 4, x squared, let's use x squared minus 4. We could factor this by doing x plus 2 and x minus 2. Because the square root of x squared is x, square root of 4 is going to be positive or -2. And notice if we were to fold this out, our middle terms would cancel out and we'd be left with x squared minus 4. I'm not going to be too harsh on if you fully factor out something with squared, but if we'll get to some that have cubes in them that I want you to go ahead and fully factor out. But let's go ahead and factor this one out, just so we're talking about it. Okay. So for difference of squares, we have to figure out what our a and b is, and that's going to be the square root of each term. So for this one, the square root of x squared is going to be just x. But what is the square root of 8? It's not pretty. So we can just simplify it. Because we know that a perfect square that goes into 8 is going to be 4. So we can rewrite this as square root of 4 times 2. And then again we can take the square root of 4, bring it on the outside, which is 2, but we have to leave that square root of 2 underneath. So b is not square root of 8, it's 2 square root of 2. Same thing, we just simplified it. So now we can rewrite x squared minus 8 by using a plus b and a minus b. Our a is x in this case, our b is 2 square root of 2, so we can rewrite this as x plus 2 square root of 2, a plus b, and a minus b, x minus 2 square root of 2. Let's go ahead and bring down that x squared plus 1. Now this is fully factored. Like I said, am I going to be very particular about this case? No, because each of them have x squared, but when we get to x cubed involved in the factors, yes, I'm going to be a little particular. Alright, this is fully factored. Now what we're going to do is we are going to set these all equal to 0, and solve for x. So these would be easy to solve for because you just change the sign, right? Because if we were to set this equal to 0, we'd have to subtract 2 square root of 2 to get it by itself. So one of our x's is going to be negative 2 square root of 2. Another one's going to be positive 2 square root of 2. But on this one, we're going to have to set up an equation. So let me do it over here. X squared plus 1 equals 0. So to solve for x first, we'd have to subtract 1. So we get x squared equals negative 1. And then if we take the square root of both sides, what's the square root of negative 1? That's correct. It's going to be I or negative I. So this polynomial has 4 solutions. Negative 2 square root of 2, 2 square root of 2, I, and negative I. We have fully solved it by factoring. Alright, the one beside this one's kind of the same, so I'm not going to go over that one, so I'll skip down to number 3. Alright, number 3, I noticed has 3 terms, so we're going to have to factor like this one. However, I also noticed that all 3 of these terms have something in common. Yay! So we're going to pull out their GCF first of all, which is going to be x. They all have an x in common. So if we pull out an x from x to the 5th, we'll have x to the 4th plus x squared minus 72 equals 0. Alright, from here I'm going to just leave this x on the outside by itself, let it chill for a little while we factor the inside. So the factors of negative 72 that are going to add together to get 1, that's going to be 9 and negative 8, correct? So I'll have x squared plus 9, x squared minus 8. Again, x squared times x squared is going to give us our x to the 4th. 9 and negative 8 are going to give us our negative 72. And then 9 minus 8 is going to give us our positive 1. Alright, again, there we have our little x squared minus 8. Notice this same one as the first problem. I'm not going to make you break it back up again because, like I said, we've already done that in the first problem. We can just look at that one. So let's go ahead and solve by setting all of these equal to 0. So if we set x to 0, we'll get 0. That's one of our solutions. If we set x squared plus 9 equal to 0, we'd have to subtract 9, correct? So we'd get x squared equals negative 9. And what's the square root of both sides? Well, we'll have 3i, and we could have plus or minus 3i right here. So I have x equals 3i, or it could equal negative 3i. And like I said, this one we've already solved for. Yay. It's already up here, so we can just copy down the answer. So one of them will be x equals 2 square root of 2, and x equals negative 2 square root of 2. So this polynomial has 5 roots. Who would have thunk it? The exponent is, the highest exponent is 5, and it has 5 roots. Highest exponent is 4, and it has 4 roots. Just pointing those out, pointing it out. Alright, next one I'm going to do is this one. It has 2 terms, so it's either going to be difference of squares, which we know it can't be because it has a plus sign and there's no squared. It could be difference of cubes. Again, we know it's not because it has a plus sign, so it's sum of cubes. Yay. Alright, formula for sum of cubes is over here. I'm going to write it down, even though you should be pretty much memorizing it by now. So that's going to be ax plus b, a squared x squared minus axb plus b squared. So the only hard thing about this one is you just have to identify your ax and your b. Your ax is the cube root of your first term. So ax in this one would be x. Your b is your cube root of your second term, and this one would be 4. If you forgot how to find the cube root, you just type in your calculator 64 and then raise 2, which is this button, parentheses 1 divided by 3, third power. You get 4. Oops. Hello. Alright. So now all we have to do is just plug it in the formula. So instead of ax plus b, I'll better write it up here. It's going to be x plus 4. The next one says a squared x squared. Guys, the a is just the number in front of your x in the first term, which in this case is 1. So a squared will be 1, so we really don't have to write it. So x squared minus a times x times b, so our ax times our b is going to be minus 4x. B squared is going to be 16. Alright. Could we factor this puppy anymore? No. Could we factor this one? It looks like we could. But it has 3 terms, so we'd have to find factors of 16 that could add together to get negative 4. And that's just not going to be possible. Because first of all, if it's a positive 16 and this is negative, it means that you'll have to use 2 negative numbers, right? And here's the possible factors with all of them negative, and none of them add up to be negative 4. Boo. So this one can't be factored, but we can solve it, even if it can't be factored. And the easiest way, unless you really like completing the square, is going to be using the quadratic formula. So first, let's go ahead and solve for this one. It's really easy. X plus 4 equals 0 would be x equals negative 4. Alright, now this one I'm going to use quadratic formula, which is going to be negative b, so positive 4 plus or minus square root b squared, so 16 minus 4 times a times c. Well, our a is 1, so I'm not going to write it. All over 2a, so 2. Alright, I'm going to do what's underneath the radical. That's called the discriminant. So 16 minus 4 times 16, that's going to give me a negative 48 underneath the radical. So 4 plus or minus square root of negative 48 over 2. Well, is 48 a perfect square? No. But do I have any perfect squares that can go into 48? Yeah. 16 can go into 48 3 times, and 16 we know is a perfect square. So let's break this up into 4 plus or minus, let's go ahead and bring that I out because we know it's going to be there because of the negative. So I, square root of 16 times 3 over 2. Now we can take the square root of 16 on the outside, so it'll be 4 plus or minus 4 from the 16. I from the negative, square root of 3 over 2. And can we simplify this even more? Yes, we can, because what goes into 4, 2, and 4, that's going to be 2. So our first answer is going to be x equals 4 divided by 2 is 2, plus or minus 4i divided by 2 is going to be 2i, square root of 3. So this one has 3 roots, negative 4, 2 plus 2i squared of 3, 2 minus 2i squared of 3. And look, it has exponent of 3. Alright, I'm just going to do like one more. I'll do one that has 4 terms, that way we can get a little bit of everything. Alright, so we know if it has 4 terms, we're going to group them and pull out the GCF. So the GCF of these two will be x squared. On the inside is going to be x plus 11. Over here will be minus 1 and then x plus 11 equals 0. Alright, from here one of our binomials will be x squared minus 1 and x plus 11 equals 0. Alright, this is actually difference of squares, so we can go ahead and simplify x squared minus 1 even more. What's the square root of x squared? That's going to be x. What's the square root of 1? That's 1, or minus 1, plus or minus. So from difference of squares, we know we can break this up into x plus 1 and x minus 1. And this is x plus 11 still. So we'll have 3 zeros because we know the highest power is 3. and one of them will be at -1, +1, and -11. And to check any of these, you can just plug any of these x values back in for x, and it should give you 0 every time. I guess everything else, I've done one example of each. I'm not going to go over one of these because that one's just factoring like we've been doing. Alright, that about covers it. I will have these answers on Google Classroom if you want to check yours, but I'll be checking this on Friday for completeness, the whole worksheet. So if you want to check your answers, you can get on Google Classroom. Bye guys.